Alright, in this last video we're going to kind of look at that direction of a vector before. So certainly if you need to use compass directions out in the real world, like that's fine. You can say, you go 4 miles north. Great, that's a vector. But mathematically, it's often more convenient or more accurate for us to discuss vectors using angles. So what we're going to look at is that second component in this video of a vector, and so we're going to look at the direction. And so the direction of a vector is just an angle. My question is, what is an angle? And now this is where your nightmares from geometry and those proofs come back, and you're like, oh, angle side angle, angle congruence, or angle similarity. Yeah, we're not going to do any of that. Okay, I'm just asking what a general angle is. And so to do that, I'm going to draw a picture. Okay. And I'm the world's best artist, but what we're going to say is, okay, here's our angle, okay? And remember, an angle has this common point that that both rays emanate from, called the vertex, okay? And then where we place this first ray is typically called the initial side. So this first ray is called the initial side. Oops, initial. Back up. Okay, initial side. Okay, and this is where you start measurement. And you might remember that on a protractor, and if you remember, a protractor looks like a fan of sorts, and it is measured, so it starts at 0 and goes to 180 or something like that. And so there's a little line in here that you have to always line up at 0, and then it's calibrated and with various lines on it, and tells you angles like 45 to whatever. Anyway, that's what you can use to measure angles. And then right in here, this space from the initial side to what we call the terminal side, so this terminal side is where you end measurement. But the space in between these two rays, two vectors, is our angle. Okay, so we call this angle. We either use a capital English letter for the angle, or we can sometimes use Greek letters like theta. We could use theta, we could use phi, we could use phi, or I guess those are the two common ones that we use. Okay, alpha, beta, I guess you've seen maybe alphas and betas before. So we can use a Greek letter for the angle as well. Okay, now an interesting question I have for you to think about is, what if you switch the initial and terminal sides? Is it the same angle? Well, maybe, maybe not. Okay. The other thing that you'll notice is that when I went from initial to terminal, by default, in mathematics, we take counterclockwise to be the positive direction. Counterclockwise is positive direction. Okay. And so on here, that's the basic idea of an angle, okay, which you might already know. But beyond that, I mentioned that a protractor measures angles, right? And so we have this 0, 45, and then 180, right? Those are all measurements of angles using degrees. And here we can see that when we measure angles, there's two ways to measure angles. We can either use degrees to measure angles, or we can use what are called radians to measure angles. And so the degrees, that when we measure it, we always imagine working on a circle. And you might remember from geometry that in one circle there is 360 degrees. Okay, why 360? You have to ask the ancient Greeks about that. Okay, actually it's kind of an interesting story that I'll leave for you to Google. Okay, but anyway, in a circle, we define from the center of the circle out to the edge going to the very right. We define that as the 0 degree mark. Okay, and then from there, okay, if we go all the way around, then we also eventually get back to saying that this is 360 degrees because we have completed one circle. Okay, and then from there, we can kind of imagine that if you stopped halfway around, well, that's half of 360, so that's 180 degrees. And then similarly, you can start looking at, if you do like a quarter of the circle, that's 90 degrees. And then if you were to do an eighth, you would be at 45 degrees. And then you can do all the multiples of eighths. So I'll just draw in some dashed lines here. So this is 135 degrees. This is going to be 270 down here. This is going to be 225 degrees and 315 degrees. Okay, so just to give you a rough idea where each of these things are. So we can say, okay, well, for example, if we have a vector going here, we might say, well, it appears to be somewhere between 45 and 90 degrees. Maybe it's halfway in between. Oops. It could be halfway in between, or maybe we just want to say it's, about 60 degrees. With a lot of this, so this angle that we made here would be 60 degrees. Okay. With a lot of this, we're going to just do some estimation, like what is it about? Okay. If you're in the neighborhood, it'll be good. If you call this 60-degree angle here, if you call it 270 degrees, we're going to have a problem. Okay, so just approximate to the best of your ability. Now, the other unit of measurement for angles is called radians. And radians, mathematicians love them. Students tend to find them confusing at first. The way that they are defined is that a radian is measured, typically you use theta to represent it, but it says the angle is the ratio of arc length to the circle radius. Well, circle radius is going to be r. And then if you can imagine this distance along the circle, that's going to be your arc length. And we're going to use s to represent that. So that's how it's actually computed. Now, in reality, what this equates to is we say that there are pi radians in 180 degrees. Okay, so this is dimensional analysis all over again. Okay, so for example, on our circle, 180 would be the same as pi. 360 would be the same as 2 pi. Okay, and then thereafter you can do fractions. So like 90 would be pi over 2. Okay, and 45 would be pi over 4. Okay, and then you can look at this as 3 pi over 4. Okay, and you can just continue going around the circle. This would be 3 pi over 2, and this is going to be 7 pi over 4, and this is going to be 5 pi over 4. Okay, we use improper fractions. Okay, so anyway, now so that's kind of your basics of radian measures based on kind of nice multiples or nice components or fractions of pi. Now, something like 60 degrees, that you can convert. So 60 degrees, you can convert it actually using dimensional analysis. Okay, so 60 degrees, for example, we can convert that to radians, right? So we want radians. We typically don't write radians. They're just unitless technically, so if you have that or not, I don't really care. But we know that if we want to switch out degrees, there's 180 degrees in pi radians, and then lo and behold, you get 60 over 180 pi, which is the same as 1/3 pi, which we commonly express as pi over 3. Okay, so now that's just some information about how you can convert angles. Next, we have angle names and angle types. So there are all sorts of names here. Acute is given to angles that are under 90 degrees. Okay, so if you can imagine something like this from here to here, that angle A would be acute, and that's something that you'll see in a moment. A right angle is precisely 90 degrees, or pi over 2 radians. So, and we typically communicate that with a box, as you might remember. Obtuse is anything that is greater than 90 degrees. Okay, so this is going to be something greater than, I'll say, let me modify this. So it certainly is greater than 90 degrees, so let's call this angle A, but it's going to be less than 180 degrees. Okay, so it's going to be something like this, where it's not completely a straight line, but it's certainly greater than a right angle. A straight angle literally is a line, so we go from there to there. Here's our ray, okay. And reflex is if you have something, so this is 180 degrees. Reflex is more than 180, but also less than 360. So that would be something like this, and you're saying it looks something like that. Okay, we don't see reflex angles too often. But nevertheless, we have this. Now, this next image I'm going to show you here is extremely important, and we more or less completed that in the last slide, but if you need to, I would recommend getting this in your notebook or jotting it down, because it will be absolutely crucial to your success both in this course and in pre-calculus, more so in pre-calculus, where you have to know, okay, if we're talking about pi over 6 radians, that's 30 degrees, or maybe you have 300 degrees and you need to convert that to radians. Well, that's the same as 5 pi over 3, okay? So anyway, make sure to get this in your notes and have this on a formula sheet for a test when we get there. But until then, there is a question that I would like you to answer, and I'll put it up right now.